start. So it's 5:30, everyone. Good evening, good afternoon, and good morning to some. Welcome to DRSD 2021's Technical Session 18, Multi-Hazard Risk and Governance 4. My name is Luis Arboleda, and I am the Zoom host for this hall. The rapporteur for this session is Ms. Han Kam. Before I give the mic to our co-chairs, a few reminders. This Zoom session is being recorded. The recording will be made available upon request. If you have any objections, kindly inform us in advance. There will be a total of 10 presentations in this session. A technical session chair will be announcing each presentation and respective presenter. The discussion and Q&A portion will be held when all 10 presentations have ended. The audience can take advantage of the chat box to ask their questions and queries to the presenters. We would like to request the presenters to keep tabs on the chat box and answer any questions directed to them. If not, we may address these questions at the end of the session. Now, before we proceed to the presentations, it is my privilege to introduce to you the technical session chairs. First up, Dr. Irfan Ahmad Rana is a professional urban planner and is currently working as an assistant professor in the Department of Urban and Regional Planning, National University of Sciences and Technology, Pakistan. He is also working as a lead consultant on projects of the National Disaster Management Authority of Pakistan, FAO, Zero International, and numerous research projects. Welcome to the session, Dr. Irfan Rana.
Thank you very much, sir. Thank you for introducing me. Hi, everyone.
Next is Dr. Parimita Mohanty, works as a program management officer for renewable energy in the UNEP Office Asia and the Pacific. She has more than 18 years of experience in sustainable energy, women's economic empowerment, and climate change. She holds an MTech degree in energy science and technology and a PhD in microgrids and smart grids from Indian Institute of Technology. Welcome to the session, Dr. Parimita Mohanty.
Thank you so much.
Okay, thank you. And you may have the floor, the two co-chairs. Welcome.
Okay, thank you very much. So welcome, Dr. Pramita, and so the moderator has already introduced us. So I will start with inviting our first presenter today. The researcher would be presenting on distance estimation based on bounded error estimation, interval analysis, and Dempster-Schaeffer theory regarding the landslide monitoring framework. So please enjoy the presentation.
Hi, I am Kidikom Savit. I'm currently a student at SIIT. Today I'm going to present our study, which is about measuring the distance between wireless sensor nodes for the landslide monitoring system. This is the presentation outline. So most of the existing wireless sensor-based landslide monitoring system consists of different sensors capturing environmental factors such as rainfall and so on. Another factor that is necessary for monitoring landslide-prone area is the displacement rate. But to the best of our knowledge, there's no study have yet adopted the wireless sensor network to measure this value. So this study aims to utilize an available wireless sensor network installed at the landslide-prone area to measure the displacement rate without other additional sensors, and also to propose a method that reduce measurement errors. Our proposed method has three concepts. The first one is localization in wireless sensor network. In wireless communication, there are two pieces of information that can be used to estimate the distance, which are receive signal strength indicator and the channel state information. However, these two information are subject to noise in the environment, and the technique that used in localization is Wi-Fi fingerprinting. In general, it has two phases. In the offline phase, we will collect the the data at the reference distances and use it to train a model. And in the online phase, we will use the data from test distance and use the train model to estimate the distance of the transmitter node. And our proposed method use our error state estimation with interval analysis. And for nonlinear dynamical system, the state space is represented by these equations. And since the problem about error state estimation can be considered as a constraint satisfaction problem, so it can be solved by using the forward backward propagation technique of interval analysis, as shown in this diagram. And we also use the Dempster-Shafer theory to represent partial knowledge as well as uncertainty and imprecise information. A framework called multi-value mapping is used in this work. It models the relationship among the underlying space, the power sets of the frame of distance, mean, and masses. So I'm going to explain how our proposed method works. First, we formulate the state space equation using these two formulas, and where interval x is an interval of the distance between two nodes, and interval c is an interval of the distance measured by some source. And then we will assign mass to all of the variables. And then construct the set S, and the set S is the n-tuple combination of all the variables, and then check whether if set S is not empty or not. If it's not empty, we will remove one member from set S and then feed it to the forward backward propagation. For example, we will remove this member and then feed it to the forward backward propagation. Then we will obtain the focal element, and then we will assign mass to this focal element by the product of two masses that are used in the previous step, and then add the obtained focal element to the set R. Once the set S is empty, we will normalize the mass of the member in the set R. Then calculate the interval expectation using this formula, and then also calculate the picnic expectation using this formula. And the picnic expectation is the estimation result output. So to prove the concept of our proposed method, we set up the experiment in our laboratory, by we use a ESP INO32 cam as the transmitter and the receiver. In the offline phase, we collect 100,000 data of RSSI and CSI and use Gaussian filter to pre-process and use the data to train random forest models separately, one for RSSI and another for CSI. In the online phase, we collect 10,000 data and use the same Gaussian filter to pre-process them, and then estimate the distance using the RSSI and CSI model, also our proposed method. And as you can see, the RSSI fluctuates, and due to the multi-path effect in the wireless communication, and CSI shows the different patterns at the different distance. So to evaluate our proposed method, we use a root mean square error as the evaluation metric, and the simulation results show that our proposed method outperforms the conventional methods. as shown here. Also, come to the conclusion of this study. We can utilize existing wireless sensor network to measure the displacement rate by using information related to the distance between the transmitter and the receiver. However, wireless sensors are subject to noise from the environment, causing error in the estimation. So to minimize the error, we propose a framework based on bound error estimation method. In interval analysis, where the density shuffle theory is used to model uncertainty of our variables. And the simulation results show that our proposed method outperform the conventional ones. In addition, we use inexpensive sensor nodes, so the system is cost effective for a large-scale early warning system. So thank you for your attention.
Okay, thank you very much. Yeah, thank you very much, Katakom. So you did a very good job about introducing a novel framework and a methodology that would cut down some the cumbersome and time-consuming process of landslide modeling and monitoring. And indeed, I believe that it is a very valuable methodological contribution to the current literature on landslide risk reduction. So thank you very much. Dr. Parmita, please.
Thank you so much, Dr. Irfan. Hi, everyone. I hope everyone is fine, safe, and healthy at this moment of difficulties. And now we can go to the second presentation, which is on GIS-based SVRA for risk anticipation and disaster risk reduction by Rahim Dobaria and Dilshad Banu. So maybe we can go now. Thank you.
In Dobaria, my two colleagues are also joining with me, Dilshad Bano from Pakistan and Khwaja Momin from Afghanistan. We are associated with Aga Khan Agency for Habitat, ACA, and Agency of Aga Khan Development Network. We are going to present the case GIS-based hazard vulnerability in the risk assessment HVR approach being used in ACA. For over the 2 decades, Aga Khan Agency for Habitat (ACA) has been working on DRR and climate change adaptation programs, including a wide range of risk anticipation, prevention, mitigation, preparedness, and response initiative in Afghanistan, India, Pakistan, Tajikistan, and Syria. The HVRA framework developed around GIS technology is the fundamental and first step of ACA's work for DRR intervention and greatly help to assess the risk of more than 2,500 settlements in ACA area of operation. We have internalized the risk screening process with the scientific base. Thus, the GIS technology and HVRA approach have become the backbone for ACA, allows analyzing risk to the property and human lives. Standardized HRA methodology developed around GIS technology and using index approach determines the extent to which community are exposed to single or multiple hazard and degree of vulnerability. Basically, risk is defined based on 2 main indicators: hazard exposure and vulnerability. Each indicator has certain sub-indicator, like vulnerability is defined based on susceptibility, coping capacity, and adaptive capacity. Each sub-indicator are defined based on several parameters. Exposure index basically allows determining who is exposed and who is most, while vulnerability index allows determining who is vulnerable and who is most. HVR result, particularly risk index, helps macro level planning at the district or regional level, while exposure and vulnerability index help micro level planning within a village. HVR process consists of 4 stages as summarized on the right side. The process ensures integration of scientific information available with the national, international institution and local community knowledge through the PRA participatory risk assessment. Process start with an offsite desktop assessment followed by on-site field assessment and then validation and generate the analysis. Dissemination of the result is the final stage in which generated analysis and finding communicate to the relevant stakeholder in form of map and documents and through the presentation and discussion. The result of HVRA incorporated in the village disaster management plan this is the point where we identify intervention and develop implementation plan for the risk reduction. As a part of the process, HVRA are updated every 3 years or when the disaster strikes. We develop all the product around ArcGIS software. This is the zero database structure that helps to manage spatial and non-spatial data. It allows to creation of versioning data. So this can be used to monitor impact of DRR intervention and compare HVRA result with the previous version. GIS and HVRA have been considered as a knowledge hub for ACA's DRR work and helped decision makers and other concerned stakeholders to design an accurate operational picture of critical scenarios before, during, and after disaster. These are the list of examples. However, I will request my colleagues to specifically present HVRA use case from the field.
I'm Khaja Mumin from Akka, Afghanistan. I want to present on use of GIS and risk monitoring. The map on the top shows hazard situation before and after mitigation project. Before on mitigation, exposure to hazard has been reduced and risk minimized. HVRA maps has been helpful in making target DRR plan and preparedness. One of the high-risk Akka target villages located in north of Afghanistan witnessed severe flash flood, which washed out land, including 60% of houses. But no casualty happened due to targeted DRR interventions, including raising awareness, developing evacuation plan, evacuation drills, and response led by CERT. HVRA helped us to identify the village as high flood risk settlement and developed flood preparedness response plan using safe route and areas. Thank you.
Hello dear participants, this is Dilshad Banu from Akka, Pakistan. I will discuss few case studies from Pakistan where HVRA has been integrated into planning for disaster preparedness, response, rehabilitation and development. One of such examples is presented here, which shows the formation of glacial lake due to glacier surge and blockage of the stream. The glacier surge and flood from the lake damaged water supply, power station, bridge, houses and access road downstream. Akka has started monitoring the situation using remote sensing and GIS technology since 2018 when the lake was first formed. Since then, the formation of glacial lake and flooding is a regular phenomenon. In 2019, 2020 and recently in May 2021, again lake was formed and flooded downstream infrastructure. This image is one of the good examples of utilities of HVRA as emergency planning tool. The map is used for informed response planning for glove situation as it shows potential flooding, possible impact areas and at-risk zones. And to respond to potential disaster, decision makers can take better preparedness measures. For example, where should be the assembly area, evacuation routes, stockpile locations, safe shelter and helipad. Here is another example from one of the remote valleys in northern Pakistan. The use of HVRAs for the analysis of access issues during disasters, the impact of natural hazards on roads and potential impact sections along with the damage dimensions are shown here. The map also provides information about the mitigation options that can reduce the impact of recurrent disasters on access infrastructure. Here, I also would like to share that Akka Pakistan won the World Habitat Award 2020 Gold Award for its Integrating Indigenous Knowledge and Technology for Safer Habitat project. In this winning project, Akka Pakistan pioneered the use of HVRA, which integrates science, technology, and local knowledge for disaster risk management and sustainable habitat planning and development. Thank you very much. We are happy to answer any of your questions. You can also reach us through the email addresses as mentioned here.
Thank you so much to all the speakers. It was an excellent presentation which shows how GIS-based HVRA approaches have been adopted and addressing lots of DRR issues in Pakistan, in Afghanistan, and I'm sure other countries, other decision makers and policy makers would be benefited by seeing these approaches and strategies. So if If any of you have any questions, please put your questions in the chat box, and I'm sure the experts will respond to that. So with this, maybe over to you, Dr. Irfan.
Yeah, thank you, Pramita. So yes, it was an excellent presentation, and I was very much interested on the glove risk in Pakistan, in which due to glacier, there's a lot of risk being developed due to climate change. So it was an interesting presentation personally for me as well. Okay, so I'll like to invite the next presenter who will be presenting on the topic of predict the critical load of rectangular concrete filled steel tubes, columns with ultra high strength concrete with a software ANSYS. Please welcome to the presentation. Thank you.
Predict the critical load of rectangular concrete-filled steel tubes columns with ultra-high strength concrete with software ANSYS. One. Introduction. Concrete-filled steel tubular CFST structures numerous structural benefits and has been widely used in civil engineering structures. Overall, CFST columns exploit various advantages of steel and concrete materials by combining them together. Choi and Sao, 2010. Therefore, CFST columns offer some inherent good properties, such as high load carrying capacity, high seismic resistance, aesthetic appearance, reduced cross-section, high resistance under fire and explosion, and work faster. Chen et al. 2010, Mariano and Suda, 2003. Furthermore, poor concrete slows down local warping of steel pipes, and steel pipes eliminate the need for concrete cast reinforcement and thus resulting in rapid construction. Hu et al. 2011. CFST columns have many different types of cross-sections such as circles, squares, rectangles, ellipses, and polygons. Particularly for the circular sections CFST column, much research has been done on its structure and method of determining its behavior, as in the studies of Schneider, Shams et al., Denarden, and L. Dibbs, and Viet Linh Tran et al. CFST column is widely used because it can achieve more load carrying capacity and provides higher yield rear axle ductility due to significant restraining effect. Round section CFST columns have been adopted by design standards such as AS NZS 5100.6, Eurocode 4, ANSI GB 50956 BC. CFST columns with square and rectangular cross-sections have not been studied much. With the current development of science and technology, the method of structural simulation by finite element-based software is quite popular and highly effective. One of them is ANSYS, finite element software. To solve the above-mentioned difficult problems, this paper presents how to determine the critical load of a CFST column with square section by ANSYS finite element software. This method saves the cost of the experiment as well as details the effects of specific parameters in the Drucker-Prager model in the CFST column. 2. Method 2.1. Stress-strain relationship for steel materials. The stress-strain relationship of steel is shown in Figure 1, where epsilon y is the plastic deformation of the steel corresponding to stress epsilon y. It is the maximum strain in the yielding phase taken as 0.005. Epsilon t and Fu are the relative strain and maximum stress, respectively. The stress-strain relationship of steel is established by multilinear isotropic hardening. Poisson coefficient is taken as 0.3, yield strength is taken as 90% of its value. 2.2 Drucker-Prager model specifications for UHPC. In the case of concrete packed into a steel box, it is quite affected by the triaxial compressive properties, so the Drucker-Prager DP model is suitable for concrete reported in previous studies. To use the DP model, it is necessary to define many parameters. For this study, the simulation method also uses the Drucker-Prager model for UHPC, but considers the influence of the parameters differently from previous studies. The Poisson coefficient of UHPC material is taken as 0.25. The initial elastic modulus was obtained according to the data from the experiment. For cases where the elastic modulus is not available, the following formulas can be used. Survey results. Figure 3 relationships of critical load and 2-axis compressive strength. Figure 4, the relationship of load with tensile strength. Figure 5, the relationship of critical load with elastic modulus. Figure 6, relationship of critical load with coefficient of friction. Result of critical load of CFST column with a square cross-section. Figure 7, relationship of critical load with relative stress start nonlinear hardening. Figure 8, deformation of simulation of experimental methods. Figure 9, the load displacement relationship of CFST column. Compare results. Table 1, CFST column critical load value of rectangular cross-section. Table 2, compare the results of the simulation method with other methods. Table 1 shows the results of CFST column simulation method using ANSYS workbench, the experimental results, as well as the results from the calculation method from the Kirk standards. Table 2 shows the error of CFST column critical load with other methods. Conclusions. The method of determining the CFST column critical load by ANSYS workbench with the Drucker-Prager model gives us quite accurate results and is easy to use. Among the parameters of the Drucker-Prager model, the durability parameter of ultra-high performance concrete materials under biaxial compression greatly affects the results of the analysis, while other parameters have little influence of the critical load value. Thus, the CFST column structure, when simulated by ANSYS workbench, only needs to pay attention to the value of biaxial compressive strength, and the Drucker-Prager model is enough to analyze and find the critical load of the structure. Thank you.
Okay, thank you very much for the presentation. So the study we presented, so it is a very good comparative study with the, you have analyzed your research with the other studies you have conducted on the same thing, and you have used, I think, the finite element software, ANSYS. It is a finite software analysis, and you proposed that this Drucker-Prager model can be customized to better predict the critical load of short columns with this super high strength concrete. So that's a very good addition to the current different methods already available. So I hope this method can prove to be useful for doing finite element analysis. So thank you very much. Dr. Irfan, please.
Yeah, thank you, Dr. Irfan. Now maybe we can go to the next presentation, which is on opportunities for implementing multi-hazard impact-based forecast and warning system to achieve Sendai framework for DRR, Bangladesh, by Tahmida Sarkar Muna. So, please.
To severe hydrometeorological disasters such as cyclone, storm surges, flood, etc. Despite being a disaster-prone country, the disaster management of Bangladesh showed a tremendous success in reducing fatality rate due to disaster. Let's have a look at some statistics. The casualty number of Bhola cyclone of 1990 was more than 5 lakhs, whereas the number limited to only 128 in cyclone Amphan of 2020. However, a significant rise in damages to property and infrastructure are seen with time. If we look at the statistics closely, this apparent disconnection demands an improved early warning system in Bangladesh. Today, I would like to discuss about an improved early warning system. Greetings, everyone. Welcome to my presentation. My study topic is opportunities for implementing multi-hazard impact-based forecast and warning system to achieve Sendai framework for disaster risk reduction in Bangladesh. Myself, Tahmida Sarkar Muna, I am the lead author of this paper. Currently, I am an undergraduate final year student of Disaster and Human Security Management Department at Bangladesh University of Professionals. What is multi-hazard impact-based forecast and warning system? Multi-hazard impact-based forecast and warning system provides a comprehensive roadmap for better resilience to any community from an impending hazard and enables the individuals, community, stakeholders to respond much better than before. Besides, leading global agreements, call to action such as Sendai Framework for Disaster Risk Reduction 2015 and the Sustainable Development Goals also emphasizes the necessity of it. Our research objectives are to identify gaps in the existing early warning system in Bangladesh and to critically evaluate the significance of transformation from single hazard early warning system to a holistic approach in observing, modeling, and predicting severe weather and consequent natural hazards and anticipating their potential impact in developing countries like Bangladesh. The study conducted a narrative literature review due to its ability to address more than one question in a study. To avoid possible errors and get maximum quality output while conducting a narrative review, some strategies have been followed. The study conducted an electronic database, Science Direct, and a search engine, Google Scholar, and conducted 15 systematic searches for journal articles, books, book chapters, and policy papers published between 2000 to 2021. The used keywords are early warning system in Bangladesh, multi-hazard early warning systems, multi-hazard impact-based forecast and warning system, natural hazards, and multi-hazard early warning system. The inclusion criteria were full text availability, peer-reviewed articles, and the exclusion criteria were articles that were not published in English and articles in the press. This is the list of documents we have reviewed. After an intensive literature review, we have found some gaps in our existing early warning system. The first one is addressing the gap between forecast of any hazard and understanding of their potential impacts. In Bangladesh, warnings come from top-down organizations that do not include community and their level of understanding of the warnings and its potential impacts. Rather, it disseminated by traditional means where only disseminating the warning information is done. Moreover, the cyclone warning that exists in the coastal belt is solely formed for the navigability of fishermen. It does not contain potential impact information of the consequent cascade hazard on the coastal belt. Incorporating vulnerability and exposure information in the forecast system is our second gap. It is a fundamental gap, basically. As a result, those at risk cannot take proper actions in order to mitigate the overall adverse effects of hydrometeorological hazards, which resulted in chaos and confusion among people in the community. The third gap, what we have found, is enabling accurate warning and monitoring system. Reliable dissemination of warning is a major concern in implementing multi-hazard impact-based warning system. Unless people believe the warning signals and thoroughly understand them, it will not help much to reduce the risk of an impending hazard. Since the warning passes through a lot of tires, there is a high chance of warning manipulation. There are some opportunities Bangladesh might face after establishing an effective multi-hazard impact-based forecast and warning system. The first one is accuracy in hazard identification and monitoring. This is because multi-hazard early warning system provides accurate information that can occur and later it helps monitor the situation. The second one is common situational and risk knowledge. The third one is better decision-making capabilities. This early warning system provides information about hydrometeorological and climatological data. It helps the vulnerable community to take proper action. The fourth one is better contingency planning. And the fifth one is reduction of loss and damages. We have already mentioned loss and damages is a major issue in our country's disaster management. The multi-hazard early warning system can able to assess the risk of an imminent hazard in primary, secondary, and tertiary level. It will also work as an effective way to reduce the risk, capability to pull off economic scale and sustain the early warning mechanism. There are some recommendations we have drawn. The first one is mainstreaming multi-hazard impact-based forecast and warning system in our national policy and disaster management system. The second one is increasing collaboration and communication among all national and international organizations associated with early warning system and forecast system. The third one is initiating training facilities and education programs at local, regional, and national level for better output. The fourth one is incorporating local community for a bottom-up approach, which is essential for successful implementation. And lastly, regular monitoring for improving the quality of multi-hazard impact-based forecast and warning system while implementing. Here are some references. That's all for myself. Thank you.
Thank you so much for such an interesting and very relevant presentation. And this paper has very systematically approached and identify the gaps and propose the multi-hazard impact-based forecast and early warning system, and how can that also help the countries and bringing lots of opportunities, and also come out with very clearly defined recommendations which would be helpful for the countries and also give some ideas to other countries to follow. So thank you so much for such an well-defined paper and presentation.
Okay, thank you. Thank you, Mr. Amita, for the presentation. So now I will like to invite our next presenter, Muhammad Al-Amin and Mustafa Mahmood, and they will be presenting on the topic of multi-temporal satellite-based flood hazard mapping and its application, or a case study from Khartoum region in the North locality, Sudan. So please, yes.
First of all, I want to thank you for giving me this opportunity to be a part of this great international symposium. And I also want to thank the organizing committee and all the participants. We're going to speak about a multi-temporal satellite-based flood hazard mapping. Our paper speaks about, or it takes a case study of Khartoum North locality, which lies in the center of Sudan. As you can see, this is Sudan, and this is a study area which lies in the heart of the country, where the river Nile and with its tributaries, the White and Blue Niles, pass. As we know that the Blue Nile is the main tributary. It has the biggest share. It's 70% of the Nile's water. The types of flooding in Khartoum, there are two types: the riverine flood and the flash floods. The Sudan has been suffering recently and in the past years from severe floods due to the climatic change and other factors. Some factors are man-made, such as the mismanagement and the lack of good infrastructure. Then we are going to speak about the factors that has an impact, like the rainfall, the extent of the rainfall, the land use pattern and its characteristics, and the topographical and geological features, also the soil types, which has a considerable impact. These two pictures show here the Khartoum state in 1988, the flooding of the very well-known, renowned flood of 1988, and the recent flooding of 2020. This one in 1988, it was called unprecedented, as it caused great havoc at that period. Unfortunately, it happened again in 2020 after more than 30 years. Many reasons are set behind this flooding, like the population growth, the very high population growth, the climate change, and also the poor drainage infrastructures. Like we have a big amount of houses that, or people who are living in floodplains and in flood paths. So, and the objectives of this study is to generate flood hazard and risk maps so that we can be ready and have some sort of early warning in Khartoum North locality using the multi-temporal satellites and satellite imagery, GIS spatial analysis tools. Also, we want to generate land cover and producing flood risk map, which is suitable for risk assessment actions. Specific objectives are to generate flood hazard map in Khartoum North using the multi-temporal centennial satellite images for the years 2018 2019, also using the SNAP software. And also we want to generate a land use, land cover, and road affected by flooding and inundation maps, as we noticed in the recent floods that many main roads have been cut, and it caused a huge problems in terms of goods transportation and things like that. We also want to generate the normalized different water index maps for flood occurred in 4 consecutive years to 2016 to 2019. We want to apply the multi-temporal change detection analysis using the generated NDWI for the same years. Also, we want to generate flood risk map using hydrological modeling and soil classification. And eventually we want to develop a story map as online plate so that it's available for public use. For the data acquisition, we acquired the data of multi-temporal from Sentinel-1 images, and also from Sentinel-2, the digital image processing from Landsat 8 for the land cover land use, and also we used the DEM or the digital elevation model and hydraulic soil groups for the road network. For satellite image in that description, we use the SRTM digital elevation model for a resolution of 30 meters, soil map acquired into 3 hydraulic soil groups, and also the road network from the OSM. The analysis approaches and also software, we use open sources, the SNAP software and tail application. Also, we used the ArcGIS with its extensions such as the spatial analysis and ArcHydro tools. We also used the AirDAS imaging software and the image difference and export tools. This flowchart shows how the flood map and land cover map are merged together to create spatial analysis, or are processed through the spatial analysis to create the flood damage assessment. For the flood map, we had Sentinel images, we made calibration, and then we made this classification for the maps. For the Landsat images, we made the processing, supervised machine learning, classification, and then we reached the flood damage assessment. Also here, to generate the NDWI, we had the Sentinel-2 images. We make layers, we determined the boundaries, thresholds, we made differencing, and at the end, we generated the NDWI to create the change detection analysis. Here, for the vulnerability mapping, we know that to be able to have the risk, we have to multiply the hazard by the vulnerability. For the hazard, we have the digital elevation model, hydraulic modeling. We have all of these data, these processes. We did all of this. And then for the vulnerability, we make the vulnerability map, and using the Sentinel images. And then we merge them together to have the risk mapping. These results and discussion, it shows the Sentinel flood detection in 2019, 2018. It shows the apparent difference here, the difference in the Sentinel images for 2019. You can see that the extent is very high from the previous year. Also here we have the classified flood maps of 2000 and 2019 from Sentinel-1 image. We can see that the flood here is, the extent is growing in a very scary way that it needs some sort of action to be made. Also here, we have the land cover map for Khartoum from the Landsat 8. Here we can see that the effective land cover by the flood as these 3 images are merged together. Also, this map shows the successive years for the road floods. It shows the road network and how it's near the affected area. In 2019, the extent of the flood is extremely higher than the previous year. Also here we have the NDVI, the Normalized Different Vegetation Index, which shows the water extent and the levels of the flood. And at this one, we have the boundaries of the WIM in successive years. For the vulnerability map here, we can see that there are 4 ranks from 1 to 4, with the orange one shows the highest vulnerability. So we can see that some of the areas here are rank them as level 3. Here also we have the River Nile hazard. We can see that there are some areas with very high flood extent, and at this one we have the flood change between 2018-2019. We can see that there is a remarkable difference that raises many concerns here. This map here shows, that the merged flash flood hazard with the river hazard, showing lots of these blue areas show very high hazard, and the orange area shows level 3 hazard, which is very high also. The risk map here it shows that the risk is the hazard multiplied by the vulnerability. It has been multiplied using these satellite images, and then we have these results. For the conclusion, the flood maps, we know that they play a very important and significant role in the decision-making and planning, and they should be used as such. Integrating the remote sensing with special analysis and using the GIS tools can help to interpret the information and gives very handful and very useful insights to predict and plan the flood season. The flooded area in 2019 showed significant increase from the previous year, which is a result from the climatic change and population growth, the mismanagement, and many other causes. So the mapping flood extent using this satellite is very useful and handy, so it can reduce the risk significantly. Hydrological modeling described integration between the Landsat cover and classification and the DEM, so that the extent to delineating the extent to reduce vulnerability maps, and which aids eventually in the urban expansion planning. And eventually the recommendations for the future research are that the flood damage assessment is very important in the mitigation and rescue work, which could be carried, and the planning procedures regarding the prevention and warning, so that this involves the interaction between different governmental and private agencies together, so that we can have good results, and we can decrease the risk of flooding greatly. Eventually, the use of GIS and satellite image processing for the inundation mapping and flood damage. Then using the water index, which could be added to this study case to assess the impact of the 2020 flooding. Thank you.
Okay, thank you very much, Mahmood. So it was an excellent presentation, which researched on some spatial temporal analysis of different images to assess flood hazard risk, and then you incorporated the Landsat images for land cover analysis, and which you merged together to form a risk assessment. And then it is a very interesting presentation, because it has produced some kind of integrated analysis using different software, including some remote sensing software as well as GIS. So that can contribute to a very effective kind of an integrated analysis. So well done, Mahmood. So it's a very interesting for me. So thank you. Dr. Pramita, please.
Thank you, Dr. Irfan. Now we can go to the next presentation, which is on modeling soil erosion, Samanala Veva Watershed, Sri Lanka, by ADTN Kumarasiri. So please.
Dear session chair and all other participants, I'm Tisirunanatara Kumarasiri from Sri Lanka. The topic of my presentation is Modeling Soil Erosion, Samanala Watershed, Sri Lanka. Authors are ADTN Kumarasiri, Dr. EPN Uday Kumara, and Professor James C.K. Jayawardenam. Affiliation is Sabaragama University of Sri Lanka. This topic can be looked at under the following headings. Introduction. As you can see this figure, this is my study area, Samanalagar Watershed. First, we will see what is the soil erosion. Soil erosion is a complex process that involves detachment, deposition, and movement of soil particles that influenced by both wind and water. And soil erosion is nowadays, soil erosion is a serious and challenging environmental issue all over the world. And the main factors that influence to the soil erosion are rainfall intensity, soil characteristics, slope length, land use practices, and socioeconomic activities. And there are several impacts occurs because of the soil erosion. They are mainly increased risk of flash flooding, increased siltation in reservoirs, decline in soil productivity, and the sediment and attached pollutants such as toxic materials and pesticides can negatively affect water quality, aquatic habitat, and hydrological systems. And these are my objectives. So overall objective is to evaluate and map the rate of current soil erosion in Samanalawa Watershed, Sri Lanka. And specific objectives are to evaluate the soil erosion rate of the selected main sub-watersheds within the Samanalawa Watershed and get an idea about the current situation in Samanalawa Watershed, Sri Lanka. Let's move to the methodology. First, I defined the study area, then I carried out the assessment for evaluate the soil erosion in the study area by using a soil erosion model. Finally, data analysis. And study area, as I mentioned earlier, the Samanalawa Watershed was selected as my study area situated in Ratnapura district, and I selected 12 main sub watersheds within the Samanalawa Watershed. And reasons for selecting Samanalawa Watershed as a study area because it is one of the largest reservoirs in Sri Lanka, and the dam of this reservoir is primarily used for hydroelectric power generation as well as irrigation system in Sri Lanka. And soil erosion is one of the most notable type of land degradation in Samanalawa Watershed in Sri Lanka, resulting in numerous environmental and socio-economic sequences. And soil erosion assessment. Recently, numerous models have been developed to estimate the soil erosion rate of the watersheds. They are universal soil equation, revised universal soil loss equation, Honda model, and Corine model, etc. And among them, I used INVEST SDR model. It means Integrated Valuation Ecosystem Services Trade-off Sediment Delivery Ratio model. Because it is a widely used model for calculating soil erosion rate in nowadays due to its properties such as high accuracy prediction and ability to integrate more inputs variables for prediction and flexibility of usage. This figure shows the interface of INVEST sediment delivery ratio model. And then it means digital elevation model and soil erodibility map, LULC, means land use land cover map, and rainfall erosivity map and subwatershed map are the input variables used for run INVEST SDR model. I used ArcGIS software to create those maps. And let's move to the result and discussion. As a result of INVEST SDR model, it gives soil loss of the study area. It means total amount of potential soil loss except soil loss. INVEST SDR model gives sediment retention and sediment export of the study area also. Sediment retention means total amount of sediment retained due to sediment filtration through land cover, and sediment export means total amount of sediment exported to the stream. But in my study, I only consider about the soil loss in the study area, and these are the result of soil erosion rate of the sub-watershed within the Samanala watershed that given from the invest SDR model. According to the result, you can see the highest soil erosion rate can be seen in sub-watershed 5 Hirikattua area because it is heavily impacted by human activities, and also this area covers by intensive agricultural practices, mainly chena cultivation and paddy fields. And according to the result, you can see the lowest soil erosion rate can be seen in sub-watershed 10 Valio area, because this area is a very rural area, and also this area covers high forest, intensive forest patch. And this is the map of soil loss of the study area. And my conclusions are, the study revealed that the current soil erosion of the catchment varies from 0 to 3,555.7 tons hectare per year, with annual average of 139.9 tons hectare per year, which is 28 times greater than soil loss tolerance in Sri Lanka. And according to the comparison of the result of current study with the result of previous study, suggests that the current soil erosion rate in the Samanala watershed has increased significantly compared to the rate of soil erosion estimated in 2008 for the same area in Samanala watershed area, possibly due to the absence of proper soil and water conservation measures at farm level, and also due to the frequent heavy rains. And these are the recommendations. The findings of the study area suggest that the extreme eroded areas have to be protected by adopting the appropriate soil and water conservation measures, and also design the conservation planning and management practices that are reduce the soil erosion rate, which sub-watersheds lead to soil erosion. And further, it can be recommended to that two basic institutional mechanisms. They are payments for environmental services and also compensations for environmental services. These are the references. That is the end of my presentation. Thank you very much.
Thank you so much for such an interesting presentation. And I think this presentation and this paper has also covered a very important climate change impact, which is on soil erosion, which is becoming very important for this region, definitely for Asia Pacific region, with lots of soil erosion happening and more frequently. And as mentioned in this paper, it has also used one of the established model to find out the soil erosion assessments and few of the findings. And interestingly, some of the recommendations, I guess, can also be used by the stakeholders in future, specifically the recommendations on the institutional arrangement and the strategies to be adopted on how to protect the more eroded areas. So it's a nice paper and presentation with lots of findings. Thank you so much. And over to you, Dr. Irfan.
Okay, thank you, Dr. Pramita. So I would like to introduce our next presenter, Mastan Reddy Negradi. The researcher will be presenting a comparative analysis of TNK and SIM height rainfall runoff models, and that will be applied and tested in the Himavati watershed area of Cauvery Basin in India. So please, thank you.
Hi, this is Nagireddy Mastan Reddy. I'm a doctoral student at National Institute of Technology, Tiruchirappalli, India. Now I am going to present my study, comparative analysis of tank and SIM height rainfall runoff models in Hemavati watershed, Cauvery Basin, India. And my contents are introduction, literature review, study area, methodology, results, conclusions, and references. And coming back to introduction, first I'm going to discuss about hydrological cycle. It is the main part in any hydrological process, and it is also known as water cycle. The hydrological cycle is a continuous process which water is evaporated from the water surfaces and oceans and moves inland as a moist air masses and produces precipitation if the correct vertical lifting condition exists. And coming back to the rainfall runoff model, it's a mathematical model describing the rainfall runoff relation of a catchment area. In other words, the model calculates the conversion of rainfall into runoff. The rainfall runoff model is broadly divided into two categories based on model structure and spatial process. In model structure, it determines how the runoff is calculated, in which method we are going to calculate the runoff value. Here we have empirical methods, which is also known as black box models, like machine learning methods, including ANN, these methods, and conceptual model. It is based on some basic equations like water balance equations. Like this type of equations we use in this conceptual model, which with the examples are Sim-Height model, tank model, AW model. In this study, we are going to discuss about Sim-Height and tank model, which are conceptual models. And a third type is physical. Physical is also it needs more parameters and more computational speed, and it is having more disadvantages as compared to other models. Physical model needs huge number of parameters, so calculation time it took more as compared to conceptual model. So we are going to see more about conceptual model. After that, depending on the spatial process, means we are considering the watershed in three different ways. First one is lumped model, which we consider whole catchment as a single unit, and in B, which we consider the whole catchment into subcatchments, which is called a semi-distributed model. We give inputs for every sub watershed. And third one is grid type model, which is known as distributed model. We give inputs for every grid in this distributed model. Next one is literature review. These are some literatures I followed for to carry out my study. Especially Jaiswal, he did work comparing using two conceptual models, tank and AWM, with SWAT, which is a physically distributed model. He concluded that tank model performs better as compared to AWM and physically based SWAT model. And there are some references. And this is my study area, which is in India, in Karnataka state, which comes under Kaveri Basin. And for my study area, the outlet station is at Sakleshpur. Gauging station name is Sakleshpur, and river name is Hemavati, in which my drainage area is around 617 kilometers square. And these two are methods. Two methods I'm going to use. First one is tank method. Second one is Sim-Height model. In tank method, both are conceptual models. Use it for daily runoff modeling. In tank model, runoff is calculated from these four different runoffs. First one is it consists of four vertical tanks. In top tank, precipitation occurs and evaporation also occurs. If evaporation exceeds the precipitation, then the excess evaporation is taken from the bottom tank. Likewise, we do this analysis, and if the first tank fills and it contributes to the runoff as a surface discharge. If second tank fills, it contributes to runoff as a intermediate discharge. Third tank contributes as a sub-base discharge, and the fourth tank is contributed as a base discharge. This is the methodology in the tank model. And in Sim-Height model, first precipitation occurs and interception store is completely filled, and after that rainfall excess is goes to the infiltration area. And if the excess rainfall is greater than the infiltration capacity, it contributes to runoff at the infiltration excess runoff. If it not exceeds the infiltration capacity, it goes as the interflow, and later on it goes to the soil moisture function. It's subject to soil moisture function. After that, it is contributed to the groundwater. Through groundwater, it is contributed as a base flow. It consists of the three sources, which is total runoff consists of three sources. First one is infiltration excess runoff. Second one is saturation excess runoff, and third one is base flow runoff. This is a Sim-Height model, and this one is the tank model. Both are conceptual models. After that, results and discussion. I took the time period from 1992 to 2015 for this analysis. First, I took a warm-up period from 1990 to 1994, and calibration period from 1995 to 2006, and verification period from 2007 to 2015. I used optimization method, genetic algorithm, and primary objective function as an Sutcliffe criterion. This is the tank model during calibration, and this is the tank model during validation. Both are showing mostly it follows the hydrograph pattern, and mostly it predicts the values well. And this is the SIMHIDE model during calibration. This is a SIMHIDE model during the validation. It also predicts a better way. After that, these are the calibrated values and a range of parameters of tank and SIMHIDE model. Not manual calibration. It is automatically calibrated using genetic algorithm. These are the parameters. These are range of parameters is shown here, and this is for a SIMHIDE model. After the best fit criterion for calibration and validation of different models are present in the table, which shows tank model performs well as compared to SIMHIDE model in terms of NSC and correlation. These are some few conclusions I drawn from the study. Daily calibration is performed using RRR toolkit framework, using genetic algorithm as an optimization technique and NSC as an objective function. Conceptual model is well suited for this sub-watershed, Hemavati sub-watershed, and Kaveri Basin. It is in Kaveri Basin with an NSA values of 0.71 for tank model and 0.66 for SIMHIDE model. And it was noticed that tank model performs better in terms of NSA and correlation coefficient values as compared to SIMHIDE values. So tank model is performing better for predicting the stream flows. And these are some references I have used for this study, and thanking you.
Okay, thank you very much for the interesting presentation. So you did a comparative analysis on the TAC and SIMHAD models, and you found that in some aspects, the tank model was found to be a little more give you more good, or I would say more robust results as compared to the SIMHAD model. So thank you very much for the presentation. And I'll ask Dr. Pramita to please go ahead.
Thank you, Dr. Irfan. Thank you, the presenter. Now we can go to the next presentation, which is on economic impact assessment of energy resilience measures to address risks in a solar power plant, a case study of 700 kilowatt peak solar power plant in Chiang Mai, Rajabhat University by Pichayaluk Patumwong Sakon. I'm sorry if I mispronounced the name. Yeah, thank you.
Hi, my name is Pichala Patumwongsakorn from Kasetsat University. Today I'm here to present my senior project, the Economic Impact Assessment of Energy Resilient Measure. This project aims to guide and present to the stakeholders who want to use energy resilient measure to develop in the solar power plants, and this project is a case study of 702 kilowatt solar power plant at Chiang Mai Ratchapat University Marin campus. Energy resilient measures has been used widely in a lot of countries, so we insulated to study in energy resilient measure to develop in the solar power plant in Thailand. The energy resilient measure will be help the plants when the plants get attacked by the natural disaster. Here is the energy resilient assessment process. Identify threats, define impact, assess vulnerabilities, calculate risks, and then we develop the solution, or we call energy resilient measure. After first of the process has been done, we gonna calculate the risk score. The risk score is the likelihood score multiplied by variability severity score. All of this that show in this slide. This is a assessment of researchers and stakeholders of the power plant. And here we got the 7 highest league score. In number 6 and number 7 are divided from the discussion between stakeholder and researcher. So we're gonna include the number 6 and number 7 to identify the energy resilience measure. And you can see in the red color word, the Wi-Fi. The Wi-Fi is derived from the discussion between researcher and stakeholder too. So we included the Wi-Fi to identify the energy resilience measure. And here is the energy resilience measure in this solar power plant. And then we're gonna assess the economic impact. I use cost benefit analysis. I have chosen net present value and payback period as an indicator of the economic impact assessments. Cost is mean cost for each measure when we use that measure in the solar panels, and the benefit is mean risk that can be reduced in terms of money. The benefit assessment process is first we assess the impact in terms of money if no measure is taken. The second, assess impact in terms of money when measure is taken. And the third, we find the difference. And then if the effect when used measure do not occur, then we gonna multiply by likelihood for each measure. Here is the example of results. You can see in the NPV column, the back color NPV is mean positive NPV. So it means that measure is interesting. And then we calculate the payback period of the positive NPV. And here is the conclusion. The energy resilience measure will be present to the stakeholder establishing a plan for emergency response to avoid the power outage, and installing animal protection equipment, molding the glass, and shaping the tree allow the plant to avoid animal invasion, and planning a maintenance and equipment backup to avoid the animal invasions. Making signs toward the lawnmowers to avoid the moving accidents, and drawing a fire protection line and installing fire surveillance equipment to avoid the Wi-Fi. Yeah, thank you for your attention. Thank you.
Thank you so much for the presentation. I should not be biased actually, but I mean, hearing about solar power plant and the energy resilience measure, I found the presentation and the paper itself quite interesting. It was also interesting to see the way the risk score has been made, and some of the inclusion with respect to wildfire, and I also found the defensive planning as one of the instruments for the risk scoring one. Very interesting. It was also interesting to see lots of positive NPV with these interventions, and I just saw only one negative NPV in this whole cost benefit analysis part, which itself shows gives some encouraging signal that number of interventions is possible, and that has also been given in the recommendations itself. So nice paper and presentation. Thank you so much for that. Now it's over to you, Dr. Irfan.
Thank you very much. Thank you for the presenter as well. Okay, I would like to now introduce to our next presenter. The researcher would be presenting on assessing the land cover changes and its impact on the socioeconomic mobility in the Rajarhat new town agglomeration in Kolkata, India. So, presenter, kindly you can start. Thank you.
Hello, my name is Rupana Acharya. Today my presentation topic is assessing land use and land cover change and its impact on the socio-economic mobility of Rajarhat-Newton agglomeration. Land use and land cover, or LULC, of the surface act as its mirror and serve as its veil, which safeguards it from the corrosive forces operating on it. The study of the transitions or shift in LULC is conducted on the study area of Rajarhat-Newton, which is located to the north of East Calcutta wetland, which is a Ramsar site as well as a natural sewage treatment plant for the city of Kolkata. However, the rapid growth of residential, commercial and industrial development has induced the LULC change, which has an enormous impact on the local inhabitants and the regional environment. Thus, to identify the pathways of development, this study aims to quantify land use adjustment and assess the land cover impact on the socio-economic mobility of the Rajarhat-Newton from the year of 1991 to 2021. The study area of Rajarhat-Newton agglomeration is located mostly in the district of North Chobbish Pargana and partly in South Chobbish Pargana district of the state of West Bengal in India. In 1995, the government of West Bengal has designated Rajarhat-Newton as a township, and Rajarhat-Newton is developed into a peri-urban area of Kolkata with total area of 71.21 square kilometer. It became a statutory proclaimed development involving the acquisition of vast areas of cultivated land as well as water bodies for the purpose of residential, industrial and infrastructural developments. The methodology of the current study includes the use of Landsat data, which has been run through radiometric filtering and atmospheric correction. Then the spectral indices of NDVI, NEWI and BUI has been generated from the Landsat data along with the band matrices, and then they have been merged. After the band merge, the textual feature of gray level co-occurrence matrix has been applied to the datasets. The gray level co-occurrence matrix or GLCM consists of 8 types of texture features which generated 8 individual layers from the data. Those 8 textual features are contrast, mean, variance, dissimilarity, homogeneity, entropy, correlation, Angulus effect. Further, the principal component analysis or PCA has been applied to the 8 texture measures and FCC of the principal components is generated. Then the classifier of support vector machine or SVM has been applied to the datasets to generate final LULC classification layers. SVM comprises of 2 types of data: in-back data, which is the training data, and out-back data, which is the validating data. And the out-back data is later used for the purpose of validation. Then the prediction of land use or land cover for the year 2031 has been executed, which incorporate the road layer and elevation layer. Then, as per the adjacent meteorological chart, through the use of the change detection and area calculation of the individual LULC classes during the respective years of 1991, 2001, 2011 and 2021, along with the incorporation of census data, the impact on the socio-economy has been analyzed. These are the composite LULC layers of the distinct years considered for the current study. As it can be observed generally, there the built-up area has gradually increased from time to time, and it has mainly increased in the northern and northwestern portions of the study area. Here the graph in the upper portion is depicting the multi-temporal change in the land use and cover from 1991 to 2021, where built-up area is increasing from time to time, whereas the vegetation area is declining, as well as the water bodies are also starting to decline. The same multi-temporal change in LULC has been depicted in the form of deviation graph, which is showing that the built-up area which has been increasing positively and the vegetation and scrubland which has been declining. In the current study, the accuracy assessment of the remotely sensed data has been estimated, and it established the data distribution of subsequent information to the user. So the 4 types of accuracy assessment of land use and land cover outputs has been done, which are producer accuracy, user accuracy, overall accuracy and kappa coefficient. The producer accuracy and user accuracy during different years of the study of the distinct LULC classes has been estimated. Then the overall accuracy and kappa coefficient has been estimated during different years, which includes all the LULC classes. Now I will come to the impact of land use and cover change on the socioeconomic mobility of the study area. As a comparative bar diagram which is given in this slide, it is showing that the rural population has decreased between 1971 census year to 2011 census year, and the urban population, on the contrary, has continuously increased between 1971 to 2011. So, according to the 2001 census, Rajarhat comprised of 39 census villages and 1 census town, where in 2011 census, 7 more census towns are being included. And Rajarhat evolved from a typical agricultural region to an urban zone during the last 3 decades. During 1980s, 41.43 population of percentage lived in the urban area, which have increased to 68% by 2011. Now we will come to the discussion of the occupational shift that took place in Rajarhat Newton area between the census year 1981 to 2011. As it can be seen in the bar diagrams that the cultivation sector and the agricultural sector has shrinked from 1981 to 2011. On the other hand, the other sectors, which includes the tertiary and secondary occupation sectors, has increased both in rural as well as urban areas. And the horticulture activity has also declined by 11.94%, and non-agrarian employment prospects have been grown by 20% during the last 2 decades in the study area. So this is the prediction output of the study for the year of 2031. As per the predictions, Rajarhat Newton will witness rapid and continuous urban expansion by the year of 2031 at the expense of other adjacent LULC entities, mainly in the region's northern portion. This trend suggests that the socio-economic structure of the region will continue to evolve as a result of rapid level of urbanization. So these are the images captured by me during field visit, which are depicting various land use and land cover classes, which include vegetation, agricultural lands, water bodies, fallow lands, and an extensively growing built-up area, as it is developing into a census town of Kolkata, mainly to relieve the population pressure of Kolkata to a certain bit, a certain extent. By this, I would like to conclude my presentation. Thank you.
Okay, thank you very much for your presentation. So you discussed about some different methods to analyze the land use, land use and land cover change, and you have kind of developed a prediction model using spore vector machine, and you have utilized or harnessed the power of Google Earth Engine as well to come up with the to prove the prediction model for land use, land cover changes. So thank you very much. And yes, Dr. Pramita, would you like to introduce me, or can I introduce myself? Because the next presentation is mine.
Oh, no, thank you so much, Dr. Irfan. Yes, so that is our last presentation, and which is none other than our chair of this session. So over to you just to introduce Dr. Irfan.
Okay, thank you. So this is a presentation will be co-presented by my student, Ms. Iman Aslam. So that we will be presenting on climate risk, risk resilience with respect to mitigating through introduction of local climatic zones. So thank you very much.
Hello everyone, I am Iman Aslam from the Department of Urban and Regional Planning, NEST, Islamabad, Pakistan. And my topic is mitigating climate change risks and building urban resilience through local climate zoning. Evidences from Pakistan. This is the presentation outline. As we all know that the urban population is increasing rapidly, many people from the rural areas are moving towards the urban centers. Around 2.5 billion more people will be added to the urban population by 2050, according to the United Nations. This continuous migration is leading to the rapid urban and slum growth. If these conditions are not planned and managed accordingly, it will increase the risk of the extreme weather events. According to the AR5, the fifth assessment report published by the Intergovernmental Panel of the Climate Change, the global mean temperature has increased risk associated with the extreme events, and it is likely to increase in the future as well. Moreover, the developing countries like Pakistan are more likely to be affected by these changes due to the resources and infrastructure constraints. The German Watch Global Climate Risk Index report published in the year 2020 ranked Pakistan at the 5th spot. This clearly represents the level of exposure and vulnerability of Pakistan. To help protect people, planet, and the built environment, in 2015, the United Nations presented 17 Sustainable Development Goals. Out of these 17 Sustainable Development Goals, 2 of the SDGs are addressed in this study. One is to make cities and human settlements resilient and safe, and the other one is to take the necessary action needed to combat climate change. The urban form of the city is closely related to the urban climate. With increasing urbanization, the urban landscape is converted into the built-up land that is not only influencing thermal conditions but also affecting the local climate of the city. Generally, climate classifications are made for micro scale, rendering them useless at the micro scale. As a result, local climate zone has emerged to cover this gap and help in urban temperature studies. Basically, local climate zoning is a technique that has been used to identify the zones of climate on the local or city level. This simpler method has been given by Stewart and Okai to classify the cities. These areas are classified based upon the urban morphology, the type of the buildup, the surface cover, and structure. There are total 17 classes, out of which 10 are for the built-up areas and 7 for the vegetative zones. This is the diagrammatic representation that represents the total 17 LCZ classes that exist. Thermal differentiation exists between different LCZ classes. Generally, densely built zones are significantly warmer compared to the more open and vegetative zones. The population in the densely built zones are thus more likely to be affected by the heat stress. This situation will get worse with every passing day. So therefore, this study aims to observe the local conditions in the 2 cities of Pakistan and suggest policies for sustainable development by mitigating urban climate risks. Coming on to the methodology. 2 of the major cities of Pakistan were selected, that is Islamabad and Lahore. The major softwares that were used in the process involves Google Earth, Saga, GIS, and ArcMap. This is the processing workflow. The data was downloaded from USGS Earth Explorer site. The training areas were collected from Google Earth, and the classification was done in Saga GIS. The LCZ maps were prepared at the end, and then the measures for sustainable cities and resilient developments were provided. Going on to the results and discussion part. This is the study area map. For the region of Islamabad, 16 LCZ classes were identified. So first class LCZ1, that is compact high-rise, was not found in the study area. LCZ3 was present in the south direction, while the main commercial hub of Islamabad, that is known as Blue Area, fall in LCZ4 category. This is the LCZ map of Islamabad. We can clearly identify 2 of the most dominant classes, LCZ6, open low-rise, and compact low-rise, that is LCZ3. In the outwards, we can see bare soil as well as some other mixed development patterns. To analyze the urban morphology and surface cover characteristics, LCZ map of Lahore was also prepared. Same 16 classes were found in Lahore as well. This is the LCZ map of Lahore. You can clearly see 2 dominant classes, LCZ3 and LCZ6, and in the outwards you can see the class of low plants. You can see that there is no continuous development pattern, mixed type of developments are found in the study area, which is not only affecting the thermal and environmental conditions of the city, but also putting pressure on the conditions of the city. LCC can serve as the basis for urban temperature studies. The rising temperature is a growing concern for climatologists and urban planners. The open spaces are the green areas are needed to be planned to contain the friendly nature of the city. Apart from that, the unplanned compact low-rise development are needed to be adequately monitored. The bare soil or the sand areas mostly found in the outskirts can be easily converted into the scattered trees that can significantly reduce heat and urban climate risks in the capital city. These maps can also help formulate future plans for climate resilient and sustainable development. Apart from that, some of the recommendations from the study are as follows. Rising temperature in the cities due to the rapid urbanization and development are a matter of serious concern. In Pakistan, type of the build-up land is not considered while making master plans of the city. Up till now, many amendments have been made in the master plans of both Lahore and Islamabad, but neither of these plans incorporated the rule of built environment and structure. So therefore, there is a dire need to incorporate the LCZs in the future development plans for urban expansions and city growth to maintain the thermal comfort of the city and to promote the development that is sustainable. These maps can also be used for urban climate monitoring and to assess the urban vulnerabilities of the natural hazards. These are the references. Thank you.
Thank you so much, Dr. Irfan and the presenter. No, I definitely found this the presentation and the paper extremely useful and practical for the purpose of being used as one of the tools for developing more sustainable and making more sustainable urban planning for other cities in Pakistan. And you have considered and how meticulously the process has been developed, and this localized climate zoning itself.
Pamita, I think you muted yourself.
Oh, I'm so sorry. Thank you so very much, Dr. Irfan and the presenter. I found this presentation and the paper extremely useful and practical for the purpose of using the methodologies and recommendations which can be used for other cities in Pakistan for more sustainable urban planning. And the recommendations, particularly, I found it very relevant when it was mentioned that the type of built-up areas has not been considered in the master planning. And this kind of climate zoning map will definitely help to design a better urban settlement and cities plan in future. So thank you so very much for producing this very relevant and practical paper. And maybe a last word from you, Dr. Irfan, over to you.
Yeah, thank you, Dr. Pamita. So we tried to basically work on towards the more climate resilient development. People have been talking about how to develop city in a more climate compatible way. So land use, land cover changes. I agree that that is that is a basic thing, and now the methodology is being moved forward to a more climate resilient development. So they are incorporated that land use, land cover should not only be judged for urban city. We also need to identify some climate hotspot risk zones. So for that purpose, there's like urban heat island effect, wind temperature, urban morphology. So many different parameters can be incorporated to come up with a very good 3D model of a city. And that would really help us in analyzing where the trees are needed, where the green areas are needed, and where this high density development can be reduced or increased for that matter. So it's just this methodology is introduced in 2010 and it's still in a very infant stage, and it will take some time to really grow out. So I was just kind of experimenting with it, and I thought that I was presenting this new technology or an idea that might really help us in integrating the disaster risk reduction component and the climate change adaptation component and integrate together to fight the climate change or climate resilience. So that was from my side. And I was observing the chat section, and I did not find any particular questions targeting the presenters. So probably a participant directly asked the question from the presenters, or maybe they were quite I mean, presenter did a very good job, and this participant did not have any questions. So or the other way is that maybe the participant didn't understand a single word. So that is my opinion, that I didn't see any question. I had some small question and observations. So like overall, our session included a kind of a diverse presentation from the engineering background as well, from water engineering. Some were geared towards the social aspects, and almost almost half of them were incorporating GIS as the main component. So to me, it seems that GIS has emerged as a way forward to cater or to measure or quantify the multi-hazard risks in different areas. So that can help us in assessing what sort of governance mechanism we are going to be needing in the future. So I've seen I saw a couple of a literature review. They were focused on early warning system, and there were, I think, 2-3 presentations which focused on understanding the early warning systems. Some were focused toward landslide, maybe somewhat towards the flood mapping, and a couple of presentations focused on having a comparative analysis of different methodologies, which will really help us in cutting down some times, or maybe introducing a more robust or integrated methodology for reducing disaster risk. So I saw a methodological paper, I saw review papers, and several case studies geared towards analyzing different kind of multi-hazard risks in our society. So to me, it was quite an informative session, and I hope all our participants and presenters, they might have learned something from it, and this might have sparked some different ideas as to how to take their research in the future, their research into the future as well. So that was a short my take to the current technical session. So if there is no question, or if anyone would like to question anyone, feel free. There's a chat box is still open. And Dr. Pramita, if you want to add anything, please go ahead.
No, thank you so much, Dr. Irfan. To be honest, I learned a lot from all the papers, from all the presentations. There was something new to learn. There was something relevant, practical. And what I also observed, that there are lots of learnings, lessons, which can be shared further through maybe number of knowledge sharing platforms, and similar events in future, so that the other stakeholders in this region can also be benefited from this. So I definitely found this sessions extremely useful, specifically and personally to me, because as you can see, I work much more on climate mitigation side and less on the cross-sectoral thematic areas, but I also work a lot on digital transformations. So that's where I saw lots of utilizations of digital technologies and how it's contributing into climate change. I also feel that there are lots of cross-sectoral things which can be promoted further. And this kind of research can also lead to lots of cross-sectoral activities and future activities in future. So I found very future-looking sessions through all these different presentations. So that's all from my side. Thank you so very much to all the presenters for such an excellent, wonderful presentations. And the content of all the papers was extremely rich. Thank you.
Okay, thank you, Dr. Pramita. Thank you very much. So, Luis, over to you.
Okay, if there are no more questions from the audience, a few reminders before we conclude this session. First, I would like to thank Dr. Rana and Dr. Mohanty for doing a very great job as co-chairs in this session. This has been a very informative and fruitful session. Like, we learned a lot from different sectors and from different fields. A few reminders, the networking lounge is open. Maybe some of our participants in this session are just shy in the camera. You may use the networking lounge to comment your thoughts or to comment your questions. And also the scientific posters are also posted in the networking lounge. You may access that in the Padlet. Lastly, the keynote session 4 or the closing session will commence in just a few minutes. You may proceed to the plenary hall by clicking its link in the Padlet. Again, thank you very much, everyone, and we hope to see you in future symposiums.